In the previous class, we have worked out some problems and we understood how to formulate a right triangles using the given details like height, distance and angle of depression or angle of elevation. And from the right triangle, using trigonometric ratio, we solve the problem. Here is question number 8. An aeroplane at an altitude of 250 meters observes the angle of depression of two boats on the opposite banks of a river to be 45 degree and 60 degree respectively. Find the width of the river. Write the answer correct to the nearest whole number. So, there is an aeroplane at a height (250 meters). So, let AB be the height of the aeroplane above the river level, above river level. Let C and D be the ships on either side of the river or on opposite side of the river banks. Let C and D be the, not ships, boats, be the boats on opposite banks of the river. At B, draw a horizontal EF such that EF is parallel to CD. At B, draw a horizontal such that EF is parallel to CD. Join B and C. Also join B to D. B to D. Therefore, angle C and angle EBC, angle C and angle EBC, these angles are alternate angles. How they are alternate angles? Because EF is parallel to CD and CB is a transversal. So the angles inside the parallel lines and on either side of the transversal are alternate angles. Here those angles are angle C and angle EBC. Similarly, angle FBD and angle D, this angle D and angle FBD are also alternate angles. Also, AB is perpendicular to CD. AB perpendicular to CD. That means this angle is 90 degree and this angle also 90 degree. So we now obtained two right triangles. Some information also given, which is the angle of depression is given. The angle of depression is measured from the horizontal along the line of sight. This is actually the transversal of this parallel line, and as well as it is the line of sight when viewed from B to C. So the angle between the line of sight and the horizontal, if the angle is below the horizontal, that angle is called the angle of depression. It has been given as 45 degree at one side and 60 degree at the other side. Since alternate angles are equal, so this angle will be 45 degree and this will be 60 degree. Angle C equal to angle EBC equal to 45 degree and angle D equal to angle FBD equal to 60 degree. Now we have two right triangles and we can go for taking the trigonometric ratio for finding the distance. Let us consider each triangle. I am considering first ABC. From right triangle, ABC, tan 45 degree equal to AB by CA. The height of the aeroplane is 250 meter. So from this, CA equal to CA equal to AB divided by tan 45 degree equal to AB is 250 meter divided by tan 45 is 1. That means CA equal to how much? 250 meter. So we obtained CA when we consider this triangle. It is 250 meter. In the same way, let us consider this triangle and find out this distance AD. For that, we need to consider tan 60 degree. From right triangle ABD, tan 60 degree equal to AB by AD. AB by AD. Tan 60 is root 3. Root 3 equal to AB is 250 divided by AD. Move AD diagonally. So AD will be equal to 250 divided by root 3. And that is equal to, for simplification of this, let us multiply by root 3 on the numerator and denominator. So 250 into root 3 on multiplying the denominator, root 3 into root 3 will become 3. So divide 250 by 3, then multiply it with root 3, that is 1.7732. So the answer will become 144.341 meter. Now this is 144.341. Adding these distances, CA plus AD will give the distance between the two ships, or since the ships are on the banks of the river, it is the same as the width of the river. Therefore, we are asked to find out the width of the river. Therefore, width of the river equal to CD equal to CA plus AD, which is equal to CA is 250 plus AD is 144.341. So this will become 394.341. 394.341, and it is near to 394 rather than 395. So the answer correct to the nearest whole number is 394. The 9th question. As observed from the top of an 80-meter tall lighthouse, the angles of depression of two ships on the same side of the lighthouse of the horizontal line with its base are 30 degree and 40 degree respectively. Find the distance between the two ships. Given your answer correct to the nearest meter. So the question is, as observed from the top of an 80-meter tall lighthouse. So there is a lighthouse of 80-meter height. Say it is AB, and there are two ships on the sea, and it is in the horizontal line with the base of the lighthouse. There are two ships. So the angle of depression is always from from the horizontal. So draw a horizontal at B, horizontal EF. So the angle of depression is measured from the horizontal. The angles are 30 degree and 40 degree. So this is 30 degree since it is a lesser angle, smaller angle, and this must be 40 degree. So the corresponding alternate angles I can mark, that is the angle is from horizontal to this transversal. So on the side of this transversal, we will get the 40 degree angle. And with this transversal, the angle will be 30 degree. Let us mark the shapes as C and D. So the triangles we have is ABD and ABC. From each triangle, take tan ratio. When you consider the bigger triangle, you will get CA. When you consider the smaller right triangle, you will get DA. Subtract DA from CA so that you will get the distance between the two sheets. The distance between the two sheets is CD. So after making the initial detailing, like AB is the height of the lighthouse, let C and D be the ships. Draw a horizontal line EF such that EF is parallel to CA. Angle of depressions given are 30 degree and 40 degree. Therefore, angle C equal to angle EBF being alternate angles. Also, angle D equal to angle EBD, again due to alternate angles. Then, after writing all these details, then you need to proceed like this. From right triangle, let us consider ABC. So, from that, tan 30 degree equal to AB by CA. Tan 30 is 1 by root 3. AB is 80 meter divided by CA is the horizontal distance corresponding to the triangle ABC. So CA equal to root 3 into 80, which is equal to 1.732 into 80, and that is equal to 138.56 meter. Now let us consider the second triangle, that is ABD. From that, tan 40 degree equal to AB by DA. Tan 40 from trigonometrical table is 0.839 equal to 80 meter divided by DA. So DA is equal to 80 divided by 0.839. This is equal to 95.351. 0.351 meter. Now we can make the subtraction. The distance between the two ships. That will be equal to, this is the whole distance. From this whole distance, deduct DA, so you will get a CD. That is, the equation is the whole distance CA minus this distance DA, so that you will get CD. The distance between two ships we can write as CD here, equal to CA minus DA. This is equal to CA is 138.56 meter minus 95.351 meter. 0.351 meter, and this is equal to, on deducting this you will get 43.209 meter, and so you are asked to give the answer in to the nearest meter. So which is near to 43.209? Is it 43 or 44? 43 is near to this meter than 44. So the answer is 43 meter, nearest meter. The 10th question. In the figure given, from the top of a building AB equal to 60 meter high, the angles of depression of the top and the bottom of a vertical lamp post CD are observed to be 30 degree and 60 degree respectively. Find the horizontal distance between AB and CD, the height of the lamp post. So the figure is given here. The given figure is like this. This is 30 degree and that this angle is 60 degree. The angle of depression of the top and bottom are respectively 30 degree and 60 degree. So 30 degree is the angle of depression of the top of the lamp post CD, and 60 degree is the angle of depression of the bottom of the lamp post CD. So how we will find out? What we need to find out is the distance between the two lamp posts. This distance we need to find out. This distance, and again
this height CD, that is the height of the lamp post. How we can find out? See, this is 60 degree angle of depression and this is the transversal. So corresponding, take the transversal here and a parallel line here. So this angle is 60 degree. Then what about this 30 degree? It meets here. So from that we need to draw a horizontal so that we can mark this angle as 30 degree. So here we have two triangles. Let this point be ABCDE equal to E. So here we have two triangles. One triangle is AED and this angle is 30 degree. And we have one more triangle, which is one more right triangle, which is like this. It is A, B, and C. This is the right triangle, right angle here, and this is the right angle here. So BC and this angle is 60 degree. And one information we are given is that this distance is given. That is AB. AB is given. AB is the building and its height is given as 60 meters. Let us first find out what is BC, so that BC and the ED are equal. Okay, so from right triangle ABC, tan 60 degree equal to opposite side of 60 degree by adjacent side of 60 degree. Tan 60 is root 3 equal to AB is 60 divided by BC, which means BC equal to 60 divided by root 3. So we got BC as 60 by root 3. BC is the horizontal distance between AB and CD. So the first part we can write the horizontal distance between AB and CD, that is equal to BC, and which is equal to 60 by root 3 meter, since this 60 is in meters. BC equal to ED equal to 60 by root 3 meter. So in this triangle also we have an angle and one side known. So we can find out the other side. Take tan 30. Tan 30 degree equal to opposite side of 30 divided by adjacent side of 30, ED. Opposite side of 30 is AE only, and adjacent side of 30, ED equal to 60 divided by root 3. tan 30 is 1 by root 3. So 1 by root 3 equal to, this root 3 will go to the numerator. That is root 3 AE divided by 60. Therefore, AE equal to, keep AE here and bring all this to this side. There is a 1 by root 3 here. 60 will go to the numerator and root 3 will come to the denominator. That is equal to 60 divided by root 3 into root 3 means 3. So this is equal to 20 meter. So this distance we obtained as 20 meter. That is, this is 20. And this distance is, the whole distance is 60. So what is this distance? Distance of the lamp post. That will be the whole distance minus the distance up to here. Sorry, not distance, but height. 60 minus 20. That will be 40 will be BE, and BE will be equal to CD, the height of the lamp post. Therefore, the height of the lamp post CD equal to BE, and BE equal to AB minus AE. AB is 60 meter and AE is 20 meter. So the height of the lamp post is 40 meter. So we got the two answers. One is the horizontal distance between AB and CD, that we obtained as 60 by root 3 meter. This is the answer. This one. This is the first part and this is the second part. The 11th question. A man observes the angle of elevation of the top of a building to be 30 degree. He walks towards it in a horizontal line through its base. On covering 60 meter, the angle of elevation changes to 60 degree from 30 degree. Find the height of the building correct to the nearest meter. So the question is, a man observes the angle of elevation of the top of a building. So there is a building, say AB. The angle of elevation of the top of the building as 30 degree. So this is the horizontal line with the foot of the building. So a man observes the top of the building. So this is his line of sight. And the angle of elevation of his line of sight with the horizontal line is 30 degree. He walks towards the building. On covering how much meter? 60 meter. So this is 60 meter. Say this is C and let this be D. On covering 60 meter, the angle of elevation changes to 60 degree. If somebody is waxed towards the building, then the angle of elevation will change and eventually it will become 90 degree. When he is at the point A. So this is 60 degree. So this is a simple problem. We have two triangles, right triangles. One is ABD, A, B, D. The other right triangle is A, B, C. And ABC we have an angle 30 degree. Here we have the angle 60 degree. C and this point is, there is a point which is D. This distance is 60 meter. Problems like this we already have done. Still I am doing this problem. Let us consider these two triangles separately as before. From right triangle ABC, tan 30 degree equal to AB by CA. That is 1 by root 3 equal to AB by CA means 60 meter plus DA. I am interested in AB. So AB will be equal to root 3 is there. This will go here. 60 plus DA. This is equation number 1. Now I am considering the second triangle. From right triangle ABD, tan 60 degree equal to opposite side of 60, that is AB, by adjacent side of 60, that is DA. Tan 60 is root 3 equal to AB by DA. So AB will be equal to root 3 into DA. This is equation number 2. So we have two equations with AB equal to this value, and here we got AB at another value. So we can equate these values. I am equating the right hand side. Equating 1 and 2. Equation 1 and 2. Root 3 dA equal to this value, 60 divided by 60 plus dA divided by root 3. So I am going to multiply the whole equation by root 3. That means multiply each term on left side and as well as right side by root 3. Multiplying root 3 with this equation will give root 3 into, there is a root 3 dA equal to root 3 into 60 plus dA whole divided by root 3. That is, root 3 into root 3 is 3. 3 dA equal to this root 3 and root 3 that will be get cancelled. So that will be equal to 60 plus dA. Bring this dA to the left side. So there is a 3 dA here minus dA equal to 60. 3 dA minus dA is 2 dA equal to 60, or dA equal to 60 by 2, that will be 30 meter. So we got an answer dA, this distance. How much it is? 30 meter. So from this triangle, tan 60 will be equal to AB by AD. That we already found out. Tan 60 is equal to AB by DA, or AB equal to root 3 dA. That equation we can readily use. By equation 2, AB equal to root 3 times dA, and root 3 is 1.732 into dA we obtained as 30, so that will be equal to 51.96 meter, and so we need to submit the answer correct to the nearest meter. So 51.96 means 52 is the nearest meter. 52 meter. So we are asked to find out AB. For finding AB, we need this distance, and that distance we found out by considering these two triangles separately. So we got this distance. Then we consider this triangle and found out the height. So all these problems are either to find the height or the distance. Question number 12. From the top of a lighthouse, 100-meter high, the angles of depression of two ships on opposite sides of it are 48 degree and 36 degree respectively. Find the distance between the two ships nearest to the nearest meter. A 4 marks question. This is a simple problem, very simple problem. So I will draw the figure and you can do the rest of the calculation by yourself. So from the top of a lighthouse 100-meter high. So there is a lighthouse 100-meter high. AB is the lighthouse which is 100-meter high, and this is the horizontal that is passing through A. And there are two ships on either side of the lighthouse. One is the ship C, the other is ship, say, D, A, B, C, D. Okay. Then we need to draw a horizontal at B such that the horizontal EF such that EF parallel to CD. EF parallel to CD. All these you should mention. And the angle of depression as observed from the top of this lighthouse, angle of depression. One angle is 48 degree and the other angle is 36 degree. So this is the transversal or the line of sight, and this angle is between this above this transversal. So the other angle should be below that transversal, and that angle is this. This is 48 degree. Similarly, the angle above the transversal is 36. Therefore, angle below that transversal, that will be equal to 36 degree. So we have two right triangle because AB is perpendicular to CD. So we need to find out the distance between the two ships. This distance. How we can find out the distance? It can be found out by calculating first CA, then AD. Then adding these two distances, you will get the total distance between the ships. And the answer is 228 meter. First you consider this triangle, take tan 48 degree. Tan 48 value you can find out from the trigonometrical table. Tan 48 degree will be equal to AB by CA. From that you can find out CA. Then consider this triangle, take tan 36 degree. Again tan 36 degree can be found out from the trigonometrical table. So tan 36 degree will be equal to 100 by AD. From that you can find out AD. And after that add CA and AD. So that you will get the distance between the two ships.
The 13th question. From the top of a lighthouse of 100 meter high, the angles of depression of two ships are observed as 48 degree and 36 degree respectively. Find the distance between the two ships in the nearest meter if the ships are on the opposite sides of the lighthouse. 2. The ships are on the same side of the lighthouse. So the question contains two parts. The question is that there is a lighthouse of 100 meter high, and from the top of that lighthouse, two ships are observed, and the angle of depression is 48 degree and 36 degree. You see, this question is exactly the same as the previous question. Even the angles of depression are same, and the height of the lighthouse is also same. So therefore the answer to the first part is the same as the answer of the previous question. That is, the first part, the answer is 220 meter only. Now let us consider the second part, where in the second part the ships are on the same side of the lighthouse. AB is the lighthouse, and there are two ships. We always mark it as C and B. The angles of depression are, one angle is 36 and other angle is 48. So this is 36 degree and this is 48 degree. This 48 degree angle is between the horizontal and this transversal. That is 48 degrees above this transversal. So below that transversal will be the other alternate angle in the pair. That means it will be 48 degree. And in the same way, with respect to this transversal, This is the angle of 36 degree. The height of the lighthouse is given, that is 100 meter. See, problems like this we already had done. CD, we need to find out the distance between the two ships in this case. What we were doing is, we will find out tan 36 degree. From that we will get CA. Then we will consider this triangle. From that we will go for tan 48 degree. From that we will get DA. Then after getting CA and DA, this CA is this whole distance. From this whole distance, if DA is deducted, then we will get CD. That is the distance between the two ships. So you can find out by yourself. And the answer is CD in this case is 48 meter.